name is Gaza, and for this section, we're going to talk about nanotechnology and how the manipulation of matter on a nanoscale positively and negatively affects the society. For this part, we are going to discuss about the antecedents of nanotechnology and its importance to society, and also identify the moral and ethical questions and concerns surrounding nanotechnology. So let us first discuss what is nanotechnology. Nanotechnology is the branch of technology that deals with the manipulation of matter on a nanoscale. Basically, it is the application of extremely small things and can be used across all the other science fields such as biology, chemistry, physics, material science, and engineering. Nanotechnology is convergent, meaning to say, it brings together various fields of science through its innovation. For example, DNA silicon chips. It is converging between semiconductor science and biology with application in the medical industry. It also involves design, characterization, production, and application of structures, devices, and systems by controlling the shapes and sizes at the nanometer scale. This technology is enabling in the sense that it produces the platform and the tools to produce innovations. Now let's talk about how nanotechnology works in 3 dimensions. The first dimension involves tangible objects, which includes materials, devices, and systems. Scientists have had to develop special tools like scanning probe microscopes to see materials that are on the nanometer size scale. The second dimension deals with the passive and static objects. Example, nanoparticles that have properties different book objects, even if they have the same composition. Another thing is the active devices, those that can store information, induce energy, or change their state. And the nanofacture, which refers to the anatomically precise manufacturing, the collection of instruments and procedure. And for the third and last dimension, the direct nanotechnology, which refers to materials structured at nanoscale components. This also extends the indirect nanotechnology, which starts with nanoparticles that can be used in huge applications. With scientists and engineers continuously finding ways to make materials at the nanoscale, more and more uses of nanotechnology arise. In medicine, nanotechnology has numerous applications in the development of more effective drugs. Assisted by the view of molecules afforded by X-ray lasers, biological mechanisms can be simulated to destroy cancer cells, while it is treated by drug-bearing nanoparticles. Nanobots or molecular scale workers can employ molecular processes within the cell which can deliver drugs to specific molecular sites or even carry out surgery. It is now possible to diagnose prevalent contagious diseases like HIV or AIDS, malaria, tuberculosis, among others, with screening devices using nanotechnology. When it's perfected, this method should greatly reduce the damage treatment, such as chemotherapy does to a patient's healthy cells. Water purification systems containing nanomaterials and utilizing new membrane technologies containing variable pore size filters are now available. Nanoparticles can be used to convert the contaminating material through a chemical reaction to make it harmless. Studies have shown that this method can be successfully used to reach contaminants dispersed in the underground ponds and at much lower cost than methods which require pumping the water out of the ground for treatment. Nanoparticles are also used to prepare heat-resistant and self-cleaning surfaces such as floors and bench tops. Nanoparticles of silicon dioxide or titanium dioxide can also make a surface repel of water, thus preventing stains. Zeolites are silicon oxides and aluminum oxides that have specific nanoporous cage-like structures that are used as molecular seeds. In agriculture, novel techniques of nanotechnology applications are applied to breed crops with higher levels of micronutrients to detect pests and control food processing. Ultra-small probes on Earth services on agricultural applications and control of soil, air, and water contamination are also developed using nanotechnology. A simple, cheap, and effective way of removing arsenic in soil and water is through the use of titanium dioxide nanoparticles. Fluorinated compounds are major environmental contaminants that can be reduced using nanoscale metal particles such as iron oxide and iron nickel in conjunction with iron fillings. Silver has long been known to exhibit strong antimicrobial properties. Its activity has been enhanced with the discovery that the bactericidal properties of silver nanoparticles are dependent on both their sizes and shapes. Bio-nanotechnology can support cleaner production methods and alternative and renewable energy sources to enhance sustainability of factories. In the Philippines, nanotechnology can be applied in making sources of renewable energy accessible to many, developing medicine that would address serious diseases and improving the state of agriculture.
Good afternoon, teacher and everyone. My name is Rachel Constantino from class of 1 CMT4. What I'm about to discuss today is still about nanotechnology, but this time it's about challenges, disadvantages and advantages, and of course the ethical dilemmas that we consider in this kind of innovation. So let's get started. The advantages brought by innovation in nanotechnology comes with a price. With rapid developments in nanotech, its adverse effects becomes more visible. Minerally based nanoparticles found in cosmetics, paints, clothing, and other products are questioned as they go through sewage treatment untreated due to their undetectable size. They can be carried down by the fine silts or microplastics with both organic and organic pollutants. It means it really affects our environment. We can definitely say that these microplastics that are being carried down by the wind contributes in polluting our surroundings. Another thing is the carbon nanotubes. Carbon nanotubes is used in manufacturing electronics and batteries. It is found to have unknown harmful impacts on human body comparable to asbestos fiber. A pulmonary toxicological evaluation of single-wall carbon nanotubes indicated that it is more toxic than carbon black and the carbon quartz. As I mentioned earlier, there are advantages and disadvantages in usage of nanotechnology. But first, let me discuss the advantages. It can benefit energy sector and the manufacturing sectors. In medical world, nanotechnology is also seen as a boon since that this can help with creating with what is called the smart drugs. But like what I've said, it has disadvantages too. The disadvantages are, due to its size, it's not easy to analyze. Predicting the toxicity of nanomaterial relies heavily on info about its chemical structure since minor changes in the chemical function group could drastically change its properties. Second is, out of human studies, it is shown that passage inhaled nanoplastics into the bloodstream can cause a lot of health problems. Materials that are harmful and toxic if they are inhaled in form of nanoparticles, it may cause lung inflammation and other heart problems. Now let me discuss about the ethical dilemmas. The ethical questions about the nanotechnology in the workplace arise from the state of knowledge about the hazards of nanomaterials and the risks that they may pose to the workers. The lack of clarity on these issues requires an interim assessment of the hazards and risks that may exist in the various situations. Let me ask you a question. Should people disregard the benefits of nanotechnology? Let me answer it for you. No, definitely not. Because as I mentioned a while ago, there are both advantages and disadvantages in the usage of nanotechnology. It is imperative, therefore, the experts and government support themselves with enough knowledge on how nanotechnology works for the benefit of the society. We better enhance our knowledge about it so it can be developed and make our daily lives more modern and a lot easier. That ends our discussions. Thank you.